Hello viewer, this is your first agricultural TV station in the nation. My name is Joshua Isha. Welcome you to yet another fresh edition of the program Aqua Farming. For those of you who are tuning in for the very first time, Aqua Farming is a program that tells you all you need to know that is in the water. And today quite is going to be amazing and interesting reason because we are holistically going to be looking at the topic aquaculture in general. Aquaculture is the farming of aquatic organisms including fish, mollusks, crustaceans, and aquatic plants. Aqua farming implies some form of intervention in the rearing process to enhance production, such as regular stocking, feeding, protection from predators, and the likes. Aquaculture also implies individuals or corporate ownership of stock being cultivated for statistical purposes. Aquatic organisms are harvested by an individual or corporate body which has owned them throughout their rearing period. Contribute to aquaculture, while aquatic organisms which are exploitable by the public as a common property resources which with or without appropriate licenses are the harvest of fisheries. Stay back and take a look. Aquaculture is the farming of freshwater and saltwater organisms including mollusks, crustaceans, and aquatic plants. Unlike fishing, aquaculture, also known as aquafarming, implies the cultivation of aquatic population under controlled conditions. Mariculture refers to an aquaculture practice in a marine environment. Particular kinds of aquaculture include algae culture, fish farming, shrimp farming, oyster farming, and the growing of cultured pearls. Particularly mated include aquaponics, which integrate fish farming and plant farming. Aquaculture has been used in China since 250 BC. When the water lowered after river floods, some fishes, mainly carp, were held in artificial lakes. Their brood were later fed using nibs and silkworms' feces, while the fish themselves were eaten as a source of protein by a fortunate genetic mutation. This early domestication of carp led to the development of goldfish in the Tang dynasty. The Hawaiian people practiced aquaculture by constructing fish ponds. A remarkable example from ancient Hawaii is the construction of a fish pond dating from at least 1,000 years ago at Alekoko. According to legend, it was constructed by mythical Menuhu. The Japanese practiced cultivation of seaweed by providing bamboo poles and leather nets and oyster shells to serve as anchoring surfaces for spores. The Roman often bred fish in ponds. In Central Europe, early Christian monasteries adopted some aquacultural practices used by the Roman Empire in the Mediterranean. The practice of aquaculture gained prevalence in Europe during the Middle Age, since away from the sea coast and the big rivers, fish were scarce and thus expensive. However, improvement in transportation during the 19th century made fish early available in an inexpensive even in inland areas, causing a decline in the practice. When the first North American fish hatchery was constructed in Dildo Island, Newfoundland, Canada in 1989, it was the largest and most advanced in the world. Americans were rarely involved in aquaculture until the late 20th century, but California residents harvested wild-caught and made legal effort to manage the supply starting circa in 1900, later even producing it as a wartime resource. Actually, there was keen interest in aquaculture in the United States as early as 1859, when Stephen Ainsworth of West Bloomfield began his experiment with brook trout by 1864. Seth Green had established a commercial fish hatching operation at Caledonia Springs near Rochester by 1866. With the involvement of Dr. W. Fletcher of Concord, Mass., artificial fish hatching operations were underway in both Canada and the United States. In contrast to agriculture, the rise of aquaculture is a contemporary phenomenon. According to Professor Carlos M. Duarte, about 430 97% of the aquatic species presently in culture have been domesticated since the start of 20th century. An estimated of 106 aquatic species have been domesticated over the past decade. The domestication of an aquatic species typically involves about a decade of scientific research. Current success in the domestication of aquatic species results from the 20th century rise of knowledge on the basic biology of our aquatic species and the lessons learned from past successes and failure. The stagnation in the world fisheries and overexploitation of 20 to 300% of marine fish species have provided additional impetus to domesticate marine species, just as overexploitation of land animals provided the impetus for the early domestication of land species. In the 1960s, the price of fish began to climb as wild fish capture rates peaked and human population continued to rise. Today, commercial aquaculture exists on an unprecedented huge scale. In the 1980s, open-neck cage salmon farming also expanded. This particular type of aquaculture technology remains the minor part of the production of farmed fin fish worldwide, but possible negative impact on wild stock, which have come into question since the late 1990s, have caused it to become a major cause of controversy. In 2004, the total world population of fisheries was 140 to 5 million tons, of which aquaculture contributed 45.5 million tons, or about 32% of the total world population. The growth rate of worldwide aquaculture has sustained a rapid, averaging about 8% per annum for over 30 years, while the contribution to the total from wild fisheries have essentially flat for the last decades. Now, let's look at the environmental impact of aquaculture. The concentrated nature of aquaculture often leads to higher than normal level of fish water waste in the water. Fish waste is organic and composed of nutrients necessary in all components of aquatic food webs. In some instances, such as nearshore high-intensity operations, increased waste can adversely affect the environment by decreasing dissolved oxygen levels in the water column. Onshore circulating aquaculture system facilities using polyculture techniques and propylene-sited facilities. For example, ways to reduce, eliminate the negative environmental effects of the fish waste. Aquaculture can be more environmentally damaging than exploiting wild fisheries. Some heavily farmed species of fish, such as salmon, are maintained in the net contained environment. Unused feed and waste products can contaminate the sea floor, and cultural fish can escape from these pens. Escapes can outcompete wild fish for food and spread disease, as well as dilute wild genetic stocks through interbreeding. Farming carnivorous fish like salmon may actually increase the pressure on wild fish. As for farming, 1 kilo of farmed fish up to 6 kilo of wild fish are used for feeding. However, considerable research and commercial feed improvement during the 1990s and 2000 has lensed many of these environmental impacts. Certain forms of aquaculture, such as the culture of seaweeds and filter feeding bivalve mollusks such as oysters, clam mussels, and scallops, relatively beginning environmentally. Seaweed acts to extract nutrients such as inorganic nitrogens and phosphorus directly from the water, and filter feeding molluscan shellfish can extract organic nutrients as they feed on particulate phytoplankton and detritus. Despite the environmental concerns, aquaculture profitably could be high enough that money could go back into promoting sustainable practices. Furthermore, new methods minimize the risks of biological and chemical pollution through minimizing stress to fish, vaccinating fish, following net pens, and applying integrated pest management. Vaccines are being used more and more to reduce antibiotic use for disease and control in aquaculture. Now, let's look at types of aquaculture. Number 1, algae culture. Algae culture is a form of aquaculture involving the farming of species of algae. The majority of algae that are intentionally cultivated fall into category of microalgae, also referred to as phytoplankton or planktonic algae. Macroalgae, commonly known as seaweeds, also have many commercial and industrial uses, but due to their size and the specific requirements of the environment in which they need to grow, they do not lend themselves as readily to cultivation on a large scale as microalgae are most often harvested wild from the ocean. Number two, fish farming. Fish farming is the principal form of aquaculture. While other methods may fall under mariculture, it involves raising fish commercially in tanks or enclosures, usually for food, a facility that releases juvenile fish into the wild for recreation fishing or to supplement a species. Natural members are generally referred to as a fish hatchery. Fish species raised by fish farms include salmon, catfish, tilapia, cod, carp, trout, and others. Increasing demands on wild fisheries by commercial fishing operations have caused widespread overfishing. Fish farming offers an alternative solution to the increasing markets and demand for fish and fish protein. Now, let's look at freshwater prawn farming. A freshwater prawn farm is an aquaculture business designed to raise and produce freshwater prawn or shrimp for human consumption. Freshwater prawn farming shares many characteristics with and many of the same problems as marine shrimp farming. Unique problems are introduced by the developmental life cycle of the global annual production of freshwater prawns, excluding crayfish and crabs, in 2003 was about 280,000 tons, of which China produced some 180,000 tons, followed by India, Thailand, with some 35,000 tons each. Additionally, China produced about 370,000 tons of Chinese river crab. Integrated multi-tropic aquaculture is a practice in which byproducts from one species are recycled to become inputs for another. Fed aquaculture is combined with inorganic extractive and organic extractive aquaculture to create balanced system for environment sustainability, economic stability, and social acceptability. Multitropic refers to the incorporation of species from different tropic or nutritional levels in the same system. This is one potential distinction from the age-old practice of aquatic polyculture, which could simply be the co-culture of different fish species from the same tropic level. In this case, these organisms may all share the same biological and chemical processes with few synergistic benefits, which could potentially lead to significant shift in the ecosystem. Some traditional polyculture systems may in fact incorporate a greater diversity of species, occupying several niches as extensive cultures. With the same plant, the integrated refers to more intensive cultivation of different species in proximity of each other, connected by nutrients and energy transfer through water, but not necessarily right at the same location. Ideally, the biological and chemical processes in an integrated multi-tropic aquaculture system should balance. This is achieved through the appropriate selection and proportion of different species providing different ecosystem functions. These co-culture species should be more than just biofilters. They should also be harvestable crops of commercial value. A working integrated multi-tropic aquaculture system should result in greater production for the overall system and based on mutual benefit to the co-culture species and improve ecosystem health, even if the individual production of some of the species is lower compared to what could be reached in monoculture practices over a short period of time. Sometimes, the more general term integrated aquaculture is used to describe the integration of monocultures through water transfer between organisms for all intents and purposes. However, the term integrated multi-tropic culture and integrated aquaculture differ primarily their degree of descriptiveness. These terms are sometimes interchanged. Aquaponics, fractionated aquaculture may also be considered variations of the integrated multi-tropic aquaculture concept. Now, number 5, mariculture. Mariculture is a specialized branch of aquaculture involving the cultivation of marine organisms for food and other products in the open ocean, an enclosed section of the ocean, or in the tank ponds or raceways which are filled with seawater. An example of the latter is the farming of marine fish, prawns, or oysters in saltwater ponds. Non-food products produced by mariculture include fish meal, nutrient agar, jewelries, and cosmetics. Now, number 6, shrimp farming. A shrimp farm is an aquaculture business for the cultivation of marine shrimp for human consumption. Commercial shrimp farming began in 1970s and production grew steeply, particularly to match the market demands of Africa and the United States. The total global production of farmed shrimp reached more than 1.6 million tons in 2003, representing a value nearly of 900 million US dollars. About 75% of farmed shrimp is produced in Asia, in particular in China and Thailand. The other 25% is produced mainly in Latin America, where Brazil is the largest producer. The largest exporting nation is Thailand. Shrimp farming has changed from traditional small-scale business in Southeast Asia into a global industry. Technological advances have led to growing shrimp at ever higher densities, and broad stocks is shipped worldwide. Virtually all farmed shrimp are pennants, and just 2 species of shrimp, the Penus vanilla, the Penus vaname, Pacific white shrimp, and the Penus monodon, giant tiger prawn, account for roughly 80% of all farmed shrimps. These industrial monoculture vary substantially to disease, which have caused several regional wipes out of farm shrimps population, increasing ecological problems, repeated disease outbreaks, and pressure criticism from both the NGO and consumers countries led to changes in the industry in the late 1990s and generally stronger regulations by government in 1999. A program aimed at developing and promoting more sustainable farming practices was initiated, including governmental bodies, industry representatives, and environmental organizations.
The Agricultural Research Council of Nigeria (ARCN) coordinates the activities of research institutes and is responsible for supervision, regulation, coordination of research activities and programs of higher institutions in Nigeria. I'm Professor Hamidou Shaributu since assumption as Executive Secretary of ARCN in April 2020 has solidified the transformation of agriculture in Nigeria through strategic and meaningful execution of research fundings for improvement of the agricultural sector.
For grains, we have the parabolic solar dryers. These are specialized solar dryers used for drying agricultural produce such as whole grains, yam and cassava chips, fruits and vegetables more efficiently. It is made of a special material that concentrates the rays of the sun within the enclosure while eliminating harmful ultraviolet radiation. Products dried are free from contaminants and are hygienic.
The parabolic shaped solar dryer is a need-based technology because virtually when we travel all over the country, you will see by the roadside, you see people drying all sorts of agricultural produce. Some spread their own on bare ground, and by the time the vehicles are moving, the dust stay on the products. The reptiles will come, they will eat whatever they can eat, drop their feces and their urine on it, and the owner comes in the evening to pack everything together and still eat that product. And the product has been contaminated, and we feel this is not right, and it is part of our mandate to make sure that we set it right, and that was what led to this, so that we can solve this problem at the grassroots level. Instead of drying by the roadside, drying on just bare ground in their villages, when they have this as a drying center, everybody in the community can bring their product there, spread on the tray, and they get it dry under hygienic condition that is covered. And the dryer also have another property to screen the ultraviolet ray of the sun, which is also can cause hazard to human health.
Students and the other youths and women within the community. And this, in the aspect of training, we have two aspects of the fisheries and aquaculture. The fisheries aspect is the way to catch a fish, like a processing aspect, the catching aspect, and then when we come to the aquaculture aspect, is the breeding and then the production unit. In every aspect of agriculture sector, you need to have a seed. So the college here, our mandate is to train how to produce a fish seed, that is the fingerlings. And also, not only the fingerling production also, we also aid in producing manpower from different aspects of the community, different communities. Fishery School Baga is a very long standard. It's established in 1978, of which, for me, let me use of opportunity to say that I am also part and parcel of this college, because I graduated from this college, and that college, the college is more or less of entrepreneurship of the college, where when a student leaves the college, at least can stand by himself. Now, as we are talking about, the federal government is now talking about food security. So once if you come out from this college, you can able to at least maintain our training and then also stand by yourself, self-employment.
Since then, Professor Shaributu has operated as visionary captain by restoring the council's glory with the first ever agricultural television and radio station in Nigeria, with well-equipped studios parading state-of-the-art equipment.
The Agricultural Research Council of Nigeria also has a brand new electronic library to further promote research and visualizations of deep thoughts on agricultural development in Nigeria.
The museum, located in the Senator Abdullahi Adamu Center, is an agricultural museum saddled with the responsibility of keeping records of agricultural findings, discoveries, researches for continuity and history purposes.
The Agricultural Research Council of Nigeria is wearing a new look under the stewardship of Professor Garba Hamidu Shaributu, who says, "Alone, I am nothing, but together, I am something." ARCN,
promoting agriculture.
Many thanks for staying with us on your first agricultural TV station. Of course, you know we've been discussing aquaculture. Fish production is an important constituent of global food security and aquatic ecosystem management. Fish farming, on the other hand, is considered a key agricultural sector of food production all over the world. It's viewed as a crucial agricultural activity that can reduce nutritional deficiencies considerably on a global scale and therefore reduce poverty effectively. Interestingly, aquaculture or fish cultivation offers a major source of animal protein and contributes heavily to household diets, livelihood and economic development in many countries and regions of the world, and Nigeria is not left out. In the agricultural sector of Nigerian economy, agriculture has been recorded as the fastest growth rate since 2000. It has been growing at 13.6% per year, contributing significantly to the economic development, although in the last years, a stagnation has been observed. With that, we'll come to the end of the program Aqua Farming on this episode, where we'll look at the topic aquaculture. On behalf of the crew members who made it possible, my name remains George Forja. You can call me Aquaman any day, anytime. Bye for now.